I'm Harry Sneed. I came here to Budapest almost 40 years ago to make a first outsourced commercial test for Siemens testing the German railroad software. The first testers here in Hungary were Jobbás Tibor from the SZKI Institute and Maria Majeros from Számok. So they were the first Hungarian testers. We're talking about the year 1978, yeah? And 10 years later, no, it wasn't 10 years, only 8 years later, I would work together with Forgács István here and Somra Indras in the Academy of Science. Building the first PC test tool was made here in Hungary for testing COBOL programs on the PC. This was a very interesting test project because we had two programs running in parallel. A Pascal program was running next to the COBOL program and was monitoring the COBOL program, the data and the execution paths. So this was a novum. Okay. 40 years later, I'm still in testing. The product which I discussed today was developed not 40 years ago, but 10 years ago in Vienna for checking data, for testing data. So you know there's dynamic testing where you run programs on the computer executing with Selenium or whatever and test the web browser. And so the testing of data is offline, yeah? So you don't need a web browser, you don't need a fancy user interface, you need a fairly performant tool to get through this. So why do we deal with this data in the first place? Well, I can give a good example. Last year, I was working for the Austrian Social Security Agency, and they had built a new software system, and this system was refused by the users after they spent several million euro on it because there were too many errors. But the errors were not in the software, the errors were in the data. When they migrated the data, they made lots of mistakes. And a lot of the data had been bad from the beginning, so they were working with bad data. So you must look out for your data, especially when you do data migration. Data dependency on specific applications, you have improper normalization, misuse of stored procedures, inconsistent data updates, and insufficient data testing. So these are some of the causes of bad data quality. Well, the consequences of having bad data is that it disturbs the migration. It disrupts the migration, and it also hampers further evolution of the software which is using that data. So it leads to errors in production, delays in software development. Generally, it makes testing more difficult if you cannot rely on the data that you are using, and the bad data tends to spread throughout the database, just like a cancer infection, yeah. So these are typical data quality problems, things that you should be looking after when you're checking the data. The corpses of deleted records are still there. It has a redundant data records with duplicate keys. The database has missing records. Some point they got deleted and should not have been. Or it has records with references, foreign keys to other records which don't even exist. The data has invalid values, and it contains violations of the first normal form, for instance, arrays, views with conflicting data types and incompatible data types. So you can write a whole PhD work on the problems of data quality. I had a Chinese student in Vienna who did her master's thesis on data quality. Yeah, so she looked all the literature on data quality and found these things out. So the challenge of database testing is to get a correct reference data. We need a reference database which we can compare the actual database with. In the testing the data, we rely on the data description. The data description is in the schema. So there's a schema for SQL, there's the create table statements, and there's a schema for XML, XSD. So here we can take the original schema, say this is in the case of a migration project, and we compare it with the new schema to see that all of the data fields are still there and they are compatible with one another from the type. So when we check this data schema, this is a static analysis. We produce a report on the deficiencies and also a metric report. So you see this is the static database check. We're checking the old data structure against the new data structure to see what keys have been added, what attributes are left out, what types have changed, what types are incompatible. This is a report produced by the tool from a SQL database. It lists out the tables, the number of lines, the number of fields, data types, primary keys, foreign keys, indexes, computes the row size, and the data points and function points for making cost estimation. Then we come to the dynamic test. Well, both tests are really static. So this is just test one. The static analysis analyzes the structure of the database, compares the structure, and now we're comparing the content of the data before the test and the data after the test. In a migration like the one we're doing now for the National Archives in Vienna, where they're migrating several million different documents, where the documents are, on the one hand, are images, stored as images. On the other hand, they're stored in a relational database where all the data attributes are described. So we compare the data as it was in the old database with the data in the new database. This is the process here. We begin by reading in the assertion generator, by reading the schema into the assertion generator. So we can generate a script defining what the data should be. Of course, this script has to be modified by the tester. He puts in the value, so we generate the script of this assertion or script. This goes through a compiler. So I wrote once, 10 years ago, a compiler for this script which creates sort of bytecode. And this bytecode is what reads in the data and checks it, to see if it's what it should be. Later, I modified this tool so that you can also create new files and a new database from the assertions in the procedure. So internally, there's a symbol tables which describe where the data is, giving the position of the data, what column, what row, what is the name of the data, and so on, and you can check the value. So we're comparing really the new against the old. You see we have on the right side, on your left side, the right, the new database content, and some of the records, maybe like the B record, don't match because before the one value was 20, if you can see that, and now it's 21. It had to explain this to the people at the National Archive because they don't understand this whole thing, what I'm trying to do for them. So they say, why do you have to use a tool for this project. Why can't you just make it? And I said, look, no human being can go through millions of data records and compare all the values to see if they're right or not. How do you want to demonstrate that this data has been migrated correctly so that all of the records have been taken over, nothing is missing, and so you have to have a tool for this. The basis of comparison is the database schema, like here, the create table you see for the customers with the data and their type. Another table is offices with their data and type. And then this is this assertion script. So you compare the keys. I was just working on this process recently because somehow one of the keys was missing. But you can have several keys to any one particular record, and you compare them with one another. So if you find that the keys are matching, then you can make an assertion. You say the new city is the old city, or the new office code you can connect to an office code in another database table. You can also give in representative data. You could say here equivalence classes. So you can test equivalence classes, and you see here where the postal code is, you can also test value ranges, that it's within the range of 1,000 to 9,000. So if it's not, you're going to get an exception. And this is where the data is checked. It produces a report like this. It says that this is the postal code is 1028578. In the new database table, it was said to have been greater than 1,000, constant value. Or you can say the new value is Australia, but it should have been either USA, France, Japan, or United Kingdom. And then you have states. Some strange value is now in the state column, and it shouldn't be there. It should be California, Massachusetts, or New York. Now, you can also cross-check from one table to the other. So you can, in the old table 1, you can check the attribute 4, look up in the table 3, and you say the table 4 is the common. I use this abbreviation common for the data which is cross-checked is attribute D if the old attribute 3 is equal to tab 3 key A. So this is a way of comparing data across tables. So this is the assertion script for data cross-checking. This was made for a catalog ordering system. This was a database, not the one I'm working on now. This was made a couple of years ago. And this is also what the Chinese student wrote her master's on. She also helped me to test these different database tables. And this is a sample of an exception list. You can see the supplier number, the record, the value 1 is missing in the reference table. Or the supplier number is 9998, and it should have been 9997. Or the price, 25.23, should have been 1050. So you get all of these variations. Quite a few come up in this Austrian National Archive test. So they did not do a particularly good job in migrating the data because a lot of the fields were shifted and they don't match the specification. You might ask in this respect, why not just compare the data? Why don't we just use a standard data comparator? Because when you do migration, often the values are changed. Yeah, so in this project now in Vienna, they used to have the street, and directly after the street, it was concatenated, was the number, the house number. Well, in the new data, now there's an underline between the street and the house number. So in the assertion language, you can define these deviations. Also, the dates, you can define the differences in the dates. So that's why you have an extra description language and cannot just simply compare the data with one another. These were the statistics from this catalog ordering system. You can see that there were invalid values from total values, old rows, and the customers was 121, new rows 121, but employees, there were 23, and the new was 24. So there's slight differences in the numbers of rows and more differences in the matching columns. The payments, only 77% of the columns match. Product lines is 100%, employees 97%, offices only 68%. So this tells you where you have to look into the data where errors occur. So summarizing, I can say that dirty databases are the source of many problems in the IT world. And you can't just let them go. The data should be controlled and corrected in regular intervals. So not only after migrating the data or after your big test, you should do this frequently, like measuring the software, making an audit on the software to check the quality. You shouldn't do this also just one time. You should make it on a monthly basis at least. And here you should also check the data at least every 3 months to make sure that it's not rotting. So both structure and contents of the data need to be validated by comparing the actual status with what it should be. And what it should be, the simplest case is it should be the same as the data was before the migration. They're just comparing field for field, but this is the simplest case. And I say if the fields change, and there's a rule for changing the field, then you have to use this rule to check the data. Use data metrics to quantify the current state of the data, the size, complexity, and quality. And of course, the invalid data content should be corrected, and the inadequate data structures should be re-engineered. And for this, you need automated tools. So that was it. Thank you.
Thank you, Harry. And so let's look at the questions, I hope.
Any question?
If any of you have questions, which is not put into the Slido, just you can... David, are you here? Yeah. So, yeah. Do we have questions?
No, please use no functional rule. That's our section. No question at the moment.
No questions at the moment. Okay.
Maybe later.
So, Harry, did you analyze what are the main causes for the deviations in the data, bad quality? Like you showed something, some examples where the prices were different.
Oh, here.
Or
yeah, like this. Yeah. No, the difference is well, programming errors. Programming errors cause data, corrupt the database, because they calculate wrong values and store them in the database, and no one ever notices them. So the users usually only notice that what is presented on the user interface, or which is printed out in reports, but not all of the data in the database is displayed or printed out. It's hidden. So this hidden data will come out eventually. Yeah, so these are programming errors. And the other kinds of errors are in migration, wrong data migration.
I've seen that there were some asserts which try to check the referential integrity, to check whether the foreign key points are valid record in another table. And my question is that if there is a database constraint for this, why we need this type of asserts. I have seen an example in the assert rules.
Okay, so you're addressing the static analysis to see if the structure
So the example was about the static analysis.
Yeah.
Okay.
Remains
thanks.
the same. Yeah.
Okay. Thanks.
I mean, the order of the data in the migrated database might be different, but all of the data items should still be there. And this can be picked up in the static analysis. So you don't have to run through 1 million records to discover that.
Bit different, but did you have a case with 3 sources of data should be migrated? Okay, you know which one is the most representative, but you have to compare it with 2 others, because here there's a case of new and old database, but what when you have new and, okay, old and new, 2 news that you have to migrate to?
Yeah, I use these words new and old not consistently because in the case of migration, the new is really the new database and the old was the way it was, but this old can also be the way it should be according to the rules. So the rule defines that the salary should be greater than 5,000. Yeah? If not, then you get an exception violation. So I say there are 2 meanings for this. The new is the actual value, and the old is the value as it should be. Yeah. Did I answer your question? Yeah.
I was also thinking if this new could be 2 sources. So, for example, you have I don't know, some sort of list of keys from different authorities. This was a case that we had, and you should migrate, but you know which one is the most representative one, but you also need the keys from 2 other sources, and to compare it would automatically not by human.
Yeah, well, the problem is in the data migration, you're dependent on the rules defined by the user. So I made a big migration for the Raiffeisen Bank. They got data from their East European subsidiaries. And they collected millions of data, Moscow, Budapest, Prague, whatever. The data came to Vienna. And there was a Czech woman who wrote the rules, what the new data should be, how this new data should be put together from the old data. Sometimes they were concatenated, sometimes they were split apart, sometimes they would put special signs in them, or they would recalculate this data. And she did this for 11,000 data records. 11,000 records were defined, and she defines this, of course, she defined it in English. Yeah. So my problem was to convert this informal English description of the rules over into a semi-formal assertion definition. So and somehow you have to be able to automatically interpret the rules. And the same problem comes up with the National Archives, and it came up with the Social Security in Vienna, is the people who know the data are not IT specialists. They don't think formally. So they define the rules in a very vague way, cloudy way. And this is the weak point of this whole approach. How to get exact rules.
Okay, this would be the case of the rules themselves. It doesn't matter how much
Yeah.
you have. Okay.
The rules are ambiguous.
Thank you.
Okay, one more.
Do you maybe have some kind of double checking or cross-reference that you see that your code or your assertion code is testing well or is doing well? So, for example, that you know some kind of final check that you need to be sure that your assertions are
Correct.
Yeah, correct.
I can only do this manually. I mean, this is come back to this question, how do you prove the correctness of software? Because what is the proof of the proof of the proof? It's a recursive problem. So I can only check it manually, take it to the users and show it to them and say, is this really the rule that you meant?
I'm just wondering, from your experience, do you need it's needed, or everything went fine at the end?
For writing these assertion procedures, you don't, it's not a procedural language. It's just, there are very few commands. There's an if, an assert, when, replace, and so forth. So it's easy to learn. Yeah.
Yes, but for me, there's a lot of data and that's error-prone. That's why I'm asking. So if someone, before you made the mistake in the assertion, you can do it as well. Yeah, of course.
Yeah, the assertions are wrong, then the deviation report will also be wrong. Yeah.
Thank you.
Sure.
Thank you. So we have 3 more questions from the audience. Maybe we have, I don't know, time for one, the most popular one. If you find wrong data, how do you find what causes the deviance?
You don't know what transaction led to the error, so this question cannot be answered. It's terrible. It's a hard task to trace an error in the data back to an error in the program. Yeah. If a mismatch found in the database, in the Social Security office, they actually manually corrected the DB2 database. We go in and correct the data, the people that had access rights to the data. Is it reasonable to check data quality after the migration? Yes, of course. You should check it to get feedback to those doing the migration. And how do you motivate management to pay for regular data checking? The only way to really motivate management in anything is there has to be a catastrophe. So something terrible must happen, and then the managers are susceptible to your suggestions. Okay, thank you.